Hi, welcome to our presentation. Our presentation is about question 4. It's about diode. This is our team members for this group. Introduction for diode. Diode an electronic component that acts as a one-way switch. It conducts electric current only in one direction. Diode restricts current from the opposite direction.
Take out all required components. So the first component is DC power. Set DC power value to 15 volt. And next component is silicon diode. In this case, I'm using 1N4001 silicon diode. Use 2 silicon diode for this circuit. So next component is germanium diode. Use GF1A germanium diode. And last component is resistor. Set resistor value to 6.6 kilo ohm. Now make connections for all components. Positive DC power connect to diode 1 and diode 1 connect to diode 2. Germanium diode 3 connect between diode 1 and diode 2. Diode 3 connect to resistor, and don't forget ground. Negative resistor connect to ground. Also negative DC power connect to ground. So the connections are complete. The question asks me to measure Vout and ID. I'm going to use 2 multimeter. Take out positive DC power connections with diode 1. Then positive DC power connect to positive multimeter. And negative multimeter connect to diode 1. So this is how to measure a current. To measure a Vout, positive multimeter connect directly to positive resistor. And negative multimeter connect directly to negative resistor. Now circuit connections are complete. Then run the simulation. Click both multimeter to show the multimeter output. Multimeter output show the value of Vout and ID. Set the multimeter 1 value to ampere. The output of Vout and ID are not very accurate with theory calculation, but still compatible as theory discussed.
Zero point 0.3 is germanium diode, 0.7 is silicon diode. This is the calculation questions point. ID is 15 minus 0.3 minus 0.7 minus 0.7 divided by 6.6k equal 2.015 milliampere. Vout 2.015 milli times 6.6k equal to 13.3 volt.
Okay, now I will make a circuit bridge rectifier. Okay, I already take out the component. One power supply, one transformer with to 1N4007 diode and 3 resistor with it 4k ohm, 2k ohm, 1k ohm. Now I will connect all the components. Okay, resistor we put it out. This is the 1k. And the ground we put here. Okay, now we connect the oscilloscope to see the output. Okay, now this is output waveform bridge rectifier. Okay, thank you.
Hi, my name is Sylvain, and I will explain a little bit about the circuit for question 2. So, a bridge rectifier functions as a converter for alternating current to direct current. At positive cycle, the D1 will become forward biased and act as a closed circuit, while D2 will be reversed biased and act as an open circuit. During negative cycle, D1 will become reversed biased and act as open circuit, while D2 will be forward biased and act as closed circuit. So with that information, we can now simplify the circuit for positive cycle and calculate the value for R total and I total. By finding that, we will now be able to find the value for current at 2K resistor. By finding that, we can calculate the voltage output for the positive cycle, and a graph can be shown to illustrate the data that has been acquired. So the same step will be repeated for the negative cycle, and by acquiring all those data, we can now create a graph for this bridge rectifier circuit. And looking at the circuit, we can now find the peak inverse voltage for this circuit, and that's all.
Use function generator. Set function generator waveform to square wave. The question given input voltage as 8V peak to peak. 8V peak to peak must be converted to V peak, which is 8 divided by 2 is equal to 4. Then set the amplitude to 4V peak and 50 Hz for the frequency. Next component is capacitor. Set the capacitor value to 10 millifarad, and next component is silicon diode. Use 1N400 diode, and last component is resistor. Set the resistor value to 100 ohm. Now make connections for all components. Positive function generator connect to capacitor and make a parallel connection for diode and resistor with capacitor. Also don't forget ground. Negative resistor connect to ground and negative function generator connect to ground. Connections for clamper circuit are complete. Next, take out the oscilloscope to measure waveform output voltage during positive and negative cycle. Positive channel A connect to input voltage, negative channel A connect to ground, and positive channel B connect to output voltage. Negative channel B connect to ground. Change the segment color for positive channel B for waveform differences. Run the simulation. Click the oscilloscope to show both waveform. Set the scale for both channel A and B to 10 volt per division. The blue waveform is the output and the red waveform is the input. You can see the accuracy small rise of output waveform, which is 0.7 volt during positive half cycle as discussed in theory.
Hi, my name is Nanjo. A clamper is a network constructed of a diode, a resistor and a capacitor that shift a waveform to a different release level without changing the appearance of the applied signal. For the network that's shown, the diode will be forward biased for the positive portion of the applied signal, which is 8 volt. For the interval 0 to T/2, the network will appear as shown in the figure. The short circuit equivalent for the diode will result in 0 volt for this time interval, as shown in the sketch. During the same interval of the time constant determined by the top equal to RC is very small because the resistor has been effectively short circuit by the conductance diode and the only resistor present in the circuit. The result in that capacitor will quickly charge to the peak value of volts as shown with the polarity indicated. When the input switch to the negative state, the network will appear as shown with the open circuit equivalent for the diode determined by the applied signal and the stored voltage across the capacitor. Current through the diode from the cathode to anode. Now that resistor is back in the network, the time constant determined by the RC product is sufficiently large to establish a discharge period much greater than the period T/2, and it can be assumed on approximate basis that the capacitor holds on to all its charge and therefore voltage is during this period. Since minutes parallel with the diode and resistor, it also can be drawn in the alternative position shown in the sketch. Apply the Kirchhoff voltage law around the input loop, result in negative 16 volt, and the negative sign result from the fact that the polarity of 8 volt is opposite to the polarity defined for V node. The resulting output waveform appears in figure with the input signal. The output signal is clamped to 0 volt for the interval 0 to T/2 but maintain the same total swing as the input.
Created using Powtoon.